The last thing I want to mention on this lesson is that when we're doing definite integrals, remember that's when we're evaluating at upper and lower bounds, we're going to get a numerical answer. And sometimes it's easier to shift everything to u rather than going back to the x's. And I'll often do this when I'm doing a definite integral with u-substitution, because that way, if you plug in your u, if you change your upper and lower bounds, these things, to u values instead of x values, then you don't have to go back to x's. So let me show you that example. You can always go back to x's if you want. This is just a way to maybe kind of shortcut that. So we're going to start with a u substitution because we have a function within a function. So I'm going to set the u as x squared plus 1, which is going to make du 2x dx. I don't have 2x dx in the problem, I just have x dx, so I'll divide both sides by 2. So du over 2 is x dx. So what I'm going to do is get that in. So this x dx, that was the du over 2, and then I've got u cubed. Now, what I'm going to do next is I'm going to turn these into u values, and then I'm just going to leave the entire problem in u's. So remember, here's my formula for u's. So my lower bound is going to be when I plug in 0, because this is a 0 x value, so 0 squared plus 1 is 1. So my lower bound is now going to be 1. My upper bound, I'm going to take that same u, the same u formula, and plug in that 1 for x, 1 squared plus 1, which is going to be 2. And since I have changed those to u values, I am not going to go back to x's at all in this problem. So we'll pull out that 1/2 from 1 to 2. So let's see. That's going to give us u to the 4th, and we'll need a 1/4, and we're going to evaluate from 2 to 1. How much more space do we got here? So this is 1/8 u to the 4th, evaluated from 2 to 1. So we'll plug in the 2. So 1/8, 2 to the 4th, minus 1/8, and then plug in the 1 to the 4th. All right, 2 to the 4th is 16, so 16 divided by 8 is 2, and then we have 2 minus 1/8, so our answer is going to be 1 7/8. Okay, so if you do it this way, make sure you change everything to u's. If back at this step, once you take the antiderivative, if you'd rather replace this u with this thing and keep everything in x's, that's fine. You can do that. You just need to make sure you're doing the same thing for the whole problem. All x's are all u's. So let's check out one more like that. So here it looks like our function within a function is definitely down here. So u is going to be 2x minus 1, which makes our du 2x dx. I don't have a 2x dx, so I'm just going to divide by 2. So that's du over 2. So that's going to take care of this. That's going to take care of this. What's still in the problem? We still have an x. Okay, so if I do my u substitution now, this is going to be a u and this is going to be u, but the x on top is still stuck in the problem. So just like we did on the first one in the first video, we're going to solve this thing for x. And plug that in here. So what that's going to be, I'm going to move over here because I think I'm going to need more space on this. So that x on top is now u plus 1 over 2 all over the square root of u, and then the dx is du over 2. And I want to change everything to u's because I don't want to have to go back to x's. So I'm going to plug in right here. I'm going to plug in 1, which is going to give me -1. And then I'm going to plug in 5, which will give me 9. So I'm going to evaluate this function from -1 to 9 because those are u values. Okay, let's see. Let's pull out both of those 1/2. So it's going to be a 1/4. And then we've got that u plus 1. And then I'm going to bring the square root thing up here. It's u to the -1/2 du. I think that takes care of everything. Distribute that. Oh, we forgot -1 to 9. So definite integral. So we have -1 to 9. Distributing that, it's going to give us u to the 1/2 plus u to the -1/2 du. Okay. Antiderivative of u to the 1/2 is going to be u to the 3/2. We need a 2/3. Don't forget we've got that 1/4 out in front. And then u to the -1/2 is going to be u to the +1/2, and we need a 2 to balance that. And once we've got this all done, we're going to be evaluating from -1 to 9. I think we're okay. Looks okay so far. I'm going to distribute that 1/4, so that's going to give us 1/6 u to the 3/2 plus 1/2 u to the 1/2. Okay, so I don't know if you noticed this problem. I just now saw it. I realized when I plug in -1, this is not going to work, and that's because it was wrong. When I plug in 1 here into this thing, I get +1, not -1. So this is a +1. My apologies. I'm glad we caught that now. Okay, we're evaluating from 1 to 9, +1 to 9. That's going to make life better. Okay, so first we're going to plug in 9. So 1/6, 9 to the 3/2 plus 1/2, 9 to the 1/2 minus 1/6, 1 to the 3/2 plus 1/2, 1 to the 1/2. Okay, let's start working through this. 1/6, 9 to the 3/2. That's going to be 27/6. Then that'll reduce. 9/2 plus 3/2. Okay. Minus, at least this is easy, 1/6 plus 1/2. Really squeezing this in here. So 9/2 plus 3/2 is going to be 12/2, which is otherwise known as 6. Minus 1/6 plus 1/2 is going to be 2/3. Is that right? Yeah, 2/3. So our final answer is 5 1/3. Yeah, I think that's right. So there it is. Okay. All right, last little piece. We don't have any problems to do with this, but just a reminder. If you have an even function, even functions are symmetric about the y-axis. So if you are evaluating an even function from -a to a, so this is your -a to a, these two areas are the same, so it might be easier to just find half of that, to just evaluate from 0 to a, and then double your answer. So that's what that's saying. If you have an even function, you could just go from 0 to a value and double it. That would be fine. If you have an odd functions are fantastic because they have origin symmetry. So down here, if you're evaluating from -a to a, this is going to give you a negative area, and this is going to give you a positive area, so it's going to be 0. So that's a really nice shortcut. Both of those are really nice shortcuts that you can always manipulate your functions to utilize. So that ends our u-substitution. We will go over any questions you guys have tomorrow and make sure you understand what's going on.